Hello world. Today we're going to talk about training model using machine learning with a supervised learning. Machine learning has a three type of learning: supervised, unsupervised, and reinforced learnings. Today we're going to work on a supervised learning. I'm Professor Bonaparte, CU Denver, director for Masters in FinTech, director for externals. If you're interested in FinTech, please email me and I'll happy to work with you to join our program. Usually I have a slides explain the theory, but today I decided to go straight to the model. Suppose you work in a company and you have three clients, client A and B and C, and then they want to borrow money from the bank or from the insurance. They want to buy insurance. And your question is whether these clients, we should offer them or not, accept or decline them. So the question is, how are you going to do that? What you do is you have a data from the company that provide you a data about their income client that you have. Client one, income, debt ratio, age, credit score, and whether this client default or not. Client two, the information about client two, whether default or not. If one, that means default, did not pay back. Zero, that means this person did pay back, did not default. So you have this data. Your goal is to decide these three clients, whether you should have them or not. So how are we going to do that? We're going to use machine learning. How? We're going to create something called probability. What's a probability? What's a probability for these clients to default? So how we're going to do it? We're going to use this data to create a probability function. From the probability function, we're going to simulate the prediction for these clients. How to do that? We're going to regress a model called default. This is your Y. And I can do the Y in yellow, if you will, to distinguish the others Y from the X's. So we can put that in yellow. And then we can put the X's in different color, if you will, or just leave them white as cool. And then the goal is to create a probability. So I'm going to regress my Y over income, debt ratio, age, and credit score. C is a constant. Phi1, Phi2, Phi3, Phi4 are coefficient to estimate. Epsilon I is residual. The I is agent or individual. Like this is individual 1, individual 2. So this is 3. So this is the I. So individual 1 equals C plus 5 multiplied by income for individual 1, which is in this case 83,000 plus Phi2. We don't know it. We need to estimate debt ratio for agent 1, 57 here, and etc. How to do that? Well, what you have to go is to go to something called data. There is something data analysis. If you didn't have it, go to files, options, add ends, and there's something called go. Click the go, and you have to check box all of those. If you didn't have them, okay, so you're gonna lose those. But we need them, so we're gonna file, options, add ends, go, check the boxes. I like to check all the boxes. You didn't need all of them, but it's good to have them. And then you go to data analysis. You go to something called regression. Okay. What is your Y? Your Y is this. Remember, I'm going to use the first row. I'm going to use it. So all of this is my Y. What are my X's? My X's are those income, credit score. Borrower ID, you should not add it. This is internal for the company, the borrower ID. And then I'm going to check labels because I use the first row also. Like I say, consider the first row labeling. Okay, boom, I got results here. So I'm going to call this regression results. So let's read the results here. The R square reflect the R square, this one, reflects the fitness of the model ranges between 0, that means perfectly unfit, and 1 perfectly fit, like awesome model, perfectly fit, cannot be an error. In this case, an hour is 0.06. Is that a low? Yes, low. But for a cross section, this is called cross section data. We expect to be between 0.05 to 0.15 in cross section. That's fine. What is that cross section? I have observation here for each client, one observation for each client. For borrower ID, I have only one observation. If I have a multiple observation for over years, then that will be a panel for each one. If I have over years, suppose you add a year here, year 2000, 2001, and that will be a panel. Time series, then the time series R squared usually 0.7, 0.8. Good. I care about this now. From this, I'm going to create a machine learning. So I'm going to do copy here, paste here. I'm going to make this bigger a little bit so you can see what I'm doing. Double click, boom. So now my goal is to create a probability. So what's the probability? This person, we know this person did not default. But what's the probability ex ante when you to default is the following: equal the constant plus. So I'm going to replicate the model. Phi1 times income. This is Phi1 multiply by income plus Phi2 multiply by debt ratio. That's Phi2 multiply by debt ratio plus Phi3 times age. This is Phi3 times age plus Phi4 times the credit score. Phi4 times credit score. Boom. So this person has a probability to default is 0.7. Let's make it better. Percentage, only one decimal is enough. Cool. So this person was 70% to default, but did not this actually. Now, if you scroll it down, you get zeros here because we need to put dollars for all the J here column. We need to put dollars. So J3, because this is the model coefficient, we use them for every individual in that data. So we need to do those in dollars. Now, if you scroll it, then you have something makes sense. So these are the probability for every client to be default. But now we know that's a probability that based in the machine learning, the function give us what's the probability. But now we know this person did not default, although the probability was high. This person did default and the probability was high. So it was accurate here. I care about the clients here. Are they going to default or not? So what we're going to do, we're going to call probability. I'm going to drag all of those. I'm going to call this, delete those. I'm going to call this probability. And now I can see client A have a 53.9 to default. This client, 61% to default. This client, 43.7 to default. Now, as your company, they have to give you the policy for the company. Accept, reject, or decision, they call it. So if the company say below 50 didn't accept clients, then reject, accept. So give money to this person. So suppose after an hour, your boss give you another case, client C, client D. Suppose the income is 95,000. The score, debt ratio score is 0.83, for example. The age is 36. And the credit score, suppose 605. So what's the probability to default and not to give the money back is just to drag this 55. And then if the company below 50 will reject, then this case reject. Now, if you work in different company and say we're going to accept below 55, if the company policy is, if the probability to default below 55 accept, then that will be accept. Because the company policy is different. This one reject, accept, and this one reject. So it depends on the company policy. Your homework is to do the regression results here. So to do the probability, use the same data. I'm going to give you the Excel and do the probability and then start simulate start simulate results here. Start simulate them. So now what I'm going to do is I'm going to delete all of those regression. I'm going to delete that. I want you to do that. So I'm going to change it here, make it like 55. This one, make it 0.88, for example. This one, 0.43. This one, the age is like 39. Maybe this, change this, make it 730, for example. Okay, so I want you to redo the probability for this client and add the client E or F. Play with this, how we can do machine learning with training the model. And now I'm going to go to the slides. So today we're going to do training model using machine learning with the supervised learning. So what does that mean? My Yusuf Bonaparte, here is my email. Objective of the exercise, simulate prediction and evaluate accuracy. That's exactly what I did with the probability. It introduced machine learning training and testing concepts. So these are the testing concepts. You test those, accept or reject. And then data set, simulated loan application. If in this case was loan application, but it could be also apply for insurance, income, and the variables that you have: income, credit score, debt level. Target is, which is the outcome, whether the person will default 1, 0, 1. 1 if you default, 0 if no. We use logistic regression. The right way to do is logistic regression, but because Excel doesn't have built-in function logistic or probability regression, we're going to use an OLS. The right model to do is logistic model, but Excel doesn't have the function. You can do it with this F solver, but very complicated. I'm going to pass it. I'm going to do with OLS regression, which is exactly what I did. The model is default, whether the client will default dependent variable between 0 or 1. And it's a function of income, debt ratio, age, and credit score. The C is a constant. This is a constant. 5, 1, 2, 3, 4 are coefficient to estimate. Income, debt ratio, age, credit score, all are independent variable, and the I is for agent I or individual I. Residual, this is epsilon I is residual term, reflect the unobservable. What we learn is supervised learning, machine learning concept supervised with the logistic regression. We did OLS, but it's supposed to be logistic. The difference is not that big, by the way. Feature engineering, correlation between the Y and the X's, model prediction, model evaluation. Model projection is probability. Model evaluation is this. Model training, we train the model, use those. And generalized train test split. These are the key things for you. Your homework. Your homework, you will have this Excel, you will have the slides too. Estimate the probability, do basically the regression. You go data regression, and you click regression, this, okay. And then after that, simulate the probability and evaluate these clients. And you can add another client D, A, B, C, D, E, or F. So try to play with that, whether reject or accept. Make the policy, like policy of 55% or more. Just what is that policy? 55%, 55 or 50% maybe, 50% or less, accept, reject otherwise. So that's a policy. Let me know the policy. So then from this, you'll decide. Thank you so much. And I hope you enjoyed this exercise. Machine learning, training the machine learning, training your model so you can solve your company problem, whether to accept or reject. Thank you.